A medium-speed diesel engine with stroke-to-bore ratio 1.5 runs at 1.2 kilo RPM. Kilo RPM means your RPM there times 1000, so that is 1.2 times 1000. So yeah, and it develops a brake mean effective pressure of 10 bars when the piston race speed, that is the piston mean speed, is 9.0 meter per second. Calculate the ISF if the mechanical and thermal efficiencies are 0.85 and 0.55 respectively. We were given that our stroke to bore ratio is 1.5, our engine speed is 1200 revs per minute. That is, converting revs per minute to revs per second is divided by 60, so that is 1200 divided by 60 to give you 20 revs per second. Our brake power was given as 1000 kilopascals. Our piston speed or piston velocity was given as 9 meter per second. Our mechanical efficiency was given as 0.85 and our thermal efficiency was given as 0.55. Now we were asked to look for our indicated specific fuel consumption. We know that indicated specific fuel consumption is equal to the mass of fuel times 3600 over indicated power. But now to solve for indicated power, we don't have our indicated power. To solve for indicated power, we can either use our Wi is equal to Pi Wi is equal to Planck's, but we don't have our Pi. We have our values for L. Okay, we barely have our values for L and D. N, we don't have K, nor do we have S. In our question, we were given our piston speed. And what is the relationship? We were given our piston speed and we were given our engine speed. And piston speed and engine speed have a relationship, which is the piston speed is equal to 2ln. We don't have our L. Let's try and find L with this relationship. So we'll make L subject of the formula here. Get L is equal to piston speed over 2n to give you 9 over 2 times 20 to give you 0.225 meters. So we have our L. We'll now go also, in our question, we're given that our stroke to bore ratio is equal to 1.5. So if we're trying to, we already have our L, so let's try and make D subject of formula. That would give us D is equal to L over 1.5, that is equal to 0.225 over 1.5 equals to 0.15 meter. Now, in our question, we were given our PB. Okay, so our brake power, our brake pressure was given. We now have our L. We have the bore, that is D, to solve for A. We have N. We don't have K. We don't have S. In this scenario, what we are going to do, because the question, I believe the question itself wasn't complete, but let's still try and solve it. So since we're saying the question isn't complete, let's just assume for now. Assuming the diesel engine is a single cylinder, that is S is equal to 1, and it's a two-stroke diesel engine, that is K is also equal to 1. So we can now say that this is our brake pressure, which is 1000 times 0.225 times your area times your N times your K, which is 1 for a single cylinder. K, which is 1 for a two-stroke, and 1 again as S for single cylinder, to give you 79.5 kilowatts. Now we have our brake power, and remember now we have our brake power now, and we will say to solve for our indicated specific fuel consumption, we need our indicated power. we were given our mechanical efficiency, so we're going to use the relationship between the mechanical efficiency, the brake power, and the indicated power to find our indicated power. So we're going to do mechanical efficiency is equal to the brake power over the indicated power. Making the indicated power subject to the formula, we're going to have the indicated power is equal to the brake power over mechanical efficiency, which is your brake power given as 79.5 over mechanical efficiency, which is 0.85, to give you 93.5 kilowatts as your brake power. Now we are going to try and find our MF. So let's recall that the thermal efficiency, which was given in the question, our parameters thermal efficiency was given. What is the formula for thermal efficiency? Thermal efficiency can be written as Wi over Q. Let's make Q subject to formula here to say Q is equal to Wi over thermal efficiency. So let's say our Wi, which is indicated power, over the thermal efficiency, which is given as 0.55, is equal to 170.1 kilojoules per second. But we know now that Q is equal to MF times LCV. And from this we have our Q, we have our LCV, which is a standard if it's not given. We can use it to find our MF, which we will now put into, when we find our MF, which is making MF subject to formula, that is divide all through by LCV to give you MF is equal to Q over LCV is equal to 170.1 divided by 42,000 to give you 4.0 times 10 raised to the power minus 3 kilograms per second. We can now put that into our formula for indicated specific fuel consumption, which is MF times 3,600 all over the indicated power. We have our MF, we have our indicated power. So that is going to be 4 times 10 raised to the power minus 3 times 3,600 all over your indicated power, 93.5, to give you 0.154 kilograms per kilowatt hour. That is your final answer.